All right, hello everybody, and welcome to the last lesson of Cycle 2 of 3M Math with Miss Gilbert. Yay! Congratulations for getting through. So the last lesson we did was exponential growth applications questions. Today, we're going to use the same methods, but apply it to decay questions. So our learning goal again this time is to be able to solve problems involving exponential functions. So let's take a look at the same slide that we had for exponential growth, but today we're going to have decay. We have our exponential equation, y equals a times b to the power of x. What do each of these mean when we are solving word problems? Well, don't forget that y is the final amount that we're looking for. A is the initial amount that we're starting with. B is the decay rate, or what is the multiplier? And that's usually a percentage in these questions. Remember, if it's a decay, it has to be between 0 and 1. So if for some reason you're multiplying something that's not between 0 and 1, you know you've done something wrong when you're setting up the equation. And x, again, how many times you apply the decay rate. So I'm going to do a few examples with you, and then you're going to go ahead and try it out with some practice questions. Okay, so example 1. If a correctly inflated basketball is dropped from a height of 2.4 meters, the height of each bounce will decrease by 40%. Determine the rebound height of the basketball after 5 bounces. Okay, so let's write down all of our 4 variables, y, a, b, and x, and we need to figure out what each of these is going to be from the information in the question. So remember, y is going to be our final amount or final value. Well, we're determining the final value, right? So we're just going to put a question mark there. A is the initial amount. Well, it's starting from a height of 2.4 meters. So A is going to be 2.4. B is our constant multiplier. So it tells us that each bounce will decrease by 40%. So that means, remember when we did growth, we did 100% plus the growth rate? Well, you can imagine because this is going down, we're going to do 100% minus the decay rate. So because remember the bounce height, if it was 100%, it would just keep going up to 2.4 each time. But each bounce, it goes down by 40%. So this time we're going to go 100% minus 40 to find our multiplier, which is 60%. Don't forget, we need to change this into a decimal. So divide 60 by 100 to get it into a decimal, 0.6. And then x is how many times are we going to apply this decay rate? Well, it tells us after 5 bounces. So in this case, x is the number of bounces, which is 5. So we have all our numbers. We're going to put them into our exponential equation. So we don't have y, but we do have the other values. So we are going to plug those values into our equations. So a is 2.4, b is 0.6, and x is 5. So again, do that 0.6 to the exponent 5 first. And you should find, if you do 0.6 to the exponent, I'm just going to double check it on my calculator because yesterday, it should be about 0.078. I've rounded that, but close enough. And now once you have those two numbers, you're just going to multiply them. And it's 0.187. So remember, a good way to check that you've done this right is that this value should be lower than the original, right? Because if we're decaying, that means we're decreasing. So that means our final value should be lower than our original amount. So this is 0.187, but don't forget we need to write a therefore statement and we need to know the units. Well, the original height was in meters, so that means the final height is also going to be in meters. So therefore the rebound height after 5 bounces will be 0.19 meters. I just rounded it to 2 decimal spots because over here we had 2 digits in our original amount. I'm not going to be too worried about your rounding in these types of problems. Okay, so that's the first example. Let's do a couple more. Okay. During normal breathing, about 12% of the air in the lungs is replaced with each breath. Lungs have a capacity of about 500 milliliters. How much of the original air is left in the lungs after 5 breaths? Okay, so we have our 4 variables. We need to figure out which. We have 1, 2, 3 numbers, so which one goes with which. We know y is going to be a question mark because we are finding how much is left. We're finding the final amount. So A, how much do we start with? Well, we started with 500 milliliters of air. So that's going to be 500. How much are we changing by each time is going to be our B. So we're going to be going down by 12% each time. So remember, with decay, you're going to do 100% minus the amount it's going down by to get your multiplier. So 100 minus 12, is 88%. Change that to a decimal, 0.88. And finally, how many times are we going to apply this constant multiplier? Well, 5 times. See how we have 3 numbers in the problems and we had 3 variables to fill in for. So you just have to match up which number in the question goes with which variable. Okay, so this time number of breaths is 5. So now we have our numbers, so we can put them into our exponential equation. And there we go. So again, you're going to do your 0.88 to the 5th first. And you should get something around 0.53. I get 0.527731917, but we can just keep a couple decimal spots. That's fine. And now finally, we are going to multiply the last 2 numbers together. So 500 times 0.53 is 264. We know we're on the right track here because it's smaller than the original amount, because remember, it's decreasing each time, so it makes sense that it's going to be lower than 500. So therefore, there's about 264 milliliters of the original air left in the lungs after 5 breaths. I don't know if that's true or not. Anyone takes biology. Oh my goodness, it's snowing outside. It is Tuesday. What's the date today? April 21st. And it is a blizzard outside. Hopefully the snow doesn't stick. Okay, let's do one more example. These are half-life problems, and I want you to know how to do these specifically because you'll see these quite a bit. Half-life just means if you've done chemistry, it just means that a sample just decreases over time, and half-life is how long it takes to go down by half. That makes sense. So the half-life of uranium-232, which is a radioactive substance, is about 70 years. No, I don't know if that's true. I may have made that up. So how much of a 100-gram sample will be left after 210 years? Okay, so we've got 1, 2, 3 numbers in here. Remember, this 232 is just part of the name, so that doesn't count as one of our numbers that we're going to put in for our variables. So we've got 70 years, 100 grams, and 210 years. And, I should say, we have a half-life, so that tells us how much it decreases by. So putting our numbers for a variable, again, we're going to find the final amount after 210 years. A is how much we're starting with. How much are we starting with? Well, we're starting with 100 grams. Okay. B, it's not super obvious here because there's not a percentage in here, but the half-life gives us the clue. It goes down by a half every 70 years. So that means our rate is 50%, which is 0.5. And now X is the number of 70-year periods. Okay, because after 70 years, it goes down by half. But after 210 years, you have to figure out how many 70-year periods there are. So 210 divided by 70 gives us 3 periods. Okay, so we have A is 100, B is 0.5, and X is 3. So now we can put those on into our equation. So 0.5 to the 3 should be 0.125, but I'll just check. Yeah, 0.125 times 100 should give you 12.5. Now we started with A was in grams, so the final answer will also be in grams. So therefore, there will be about 12.5 grams left of the uranium-232 sample after 210 years. So that is it for the lesson, and that is it for the cycle. So exciting. So I do have some you try questions posted. I will also post the answers to those. Those will also be posted as a Google slideshow like yesterday, so they have the same kind of format. Once you feel comfortable with those, then you can try the 2.1 for a quiz, and then we are done the cycle. I am not going to do a test for this cycle. I'm not going to do a final assignment because you've been doing quizzes on every single topic. So starting next week, we will be starting cycle 3, which will introduce more specific quadratic stuff, a couple new trig things, sine law, cosine law. Some of you have done that already if you took the academic grade 10 class. And then we're going to get into more word problems. And that should take us through to the end of the school year. Anyway, I hope that lesson made sense. Please let me know if you have any questions. The best way to get a hold of me is using the envelope icon in Brightspace. That's in the top right-hand corner. You can send me an instant message or an email. Okay, that's it for this week, and I will talk to you next week. Bye, guys.